Okay, so our first problem here is about the Great Boston Molasses Flood. And so we have here a 2.3 million gallons of crude molasses flowing from a 30-foot high storage tank. And we have the estimated specific gravity of crude molasses at 1.4. And what we're looking for is the mass of molasses in the tank and pounds mass, and the pressure at the bottom of the tank in pounds force per inch squared. And they also want us to give at least 2 possible causes of the tragedy. So what we're going to start out doing is the first thing they ask us, and we are going to determine the mass. And to do that, we go back to the piece of information that they gave us, that the specific gravity of crude molasses is 1.4. So we know that SG, which is equal to density of the molasses over reference density, which is the density of water, is equal to 1.4. So rearrange that to get density of the molasses is equal to reference density times specific gravity. And we can plug things in here. We know the density of water is 1 gram per cubic centimeter, and our specific gravity is 1.4. So we get that the density of molasses is 1.4 grams per cubic centimeter. And now we want to convert this to units that work towards getting our final mass in the units of pound mass. So 1.4 grams per cubic centimeter. And we want to pull out the handy table that I printed out last week. And we want to convert from grams to pound mass. So we have that up here. 1,000 grams is equal to 2.20462 pound mass. And now we want to convert from centimeters cubed to gallons. And I use the same conversion table that I just showed y'all. And now we can plug all this in. And we get that our density is 11.68 pounds mass per gallon. And so then we know density is equal to mass over volume. And so we can rearrange that to get that our mass is going to be equal to our density times our volume. So here's our density, and we know our volume is given to us as 2.3 million gallons. So now we're just going to plug in M is equal to rho V, which is equal to 11.68 pounds mass per gallon. And we have 2.3 times 10 to the 6 gallons. And we get 2.68 times 10 to the 7th. Pound mass. So we solved part A. And now for the second part, they want us to get the pressure at the bottom of the tank. And we're going to go back to a formula that we have here on the first page. I'm not going to flip to that page, but I'll just write it down again. So we have P is equal to P naught. It's a P naught a rho. I just want to make that clear. Plus rho GH. And we're going to plug in here. So P naught is going to be 14.696 pounds force per inches squared plus 11.68, which we got as our density. And we're going to convert these units again. And we know we have a height of 30 feet. And let's plug all this in. And we get the pressure at the bottom of the tank is equal to 32.9 psi. And lastly, they want to know what are possible causes. And since no one is currently live, since this is not live, to give me some causes, I will just go ahead and rattle off a few causes that it could be. The most likely one, possible corrosion, I would say. Or also likely it could be a structural flaw of some sort.